Hello all. So in the last sessions, we have seen the introduction to geology and the type and formation of geology, geological formations, etc. And what are the various branches of engineering geology also we have seen. And we have seen like what is the weathering of rocks, etc. So today in this session we will be seeing in detail about the weathering of rocks. So why weathering is very important? What is the nature of weathering where the rocks are getting deteriorating? Why the external forces are breaking the rocks? Why these natural hazards are taking place? So the important property of rock, where it depends on the type of mineral in which it has been formed. So based on the type of mineral, the rock is developed by various actions that we have seen: igneous rock, metamorphic rock, sedimentary rocks, etc. So based on the type of that mineral, the strength, durability, all the physical, chemical parameters of the rock may change time to time. So these are the various effects. Before we go into the actual weathering in detail, these are the various effects in which rocks are going to get damaged. So rocks are symbols of durability and strength. Rocks are normally resistant to weathering. So last time also in the last session we have highlighted regarding physical weathering and chemical weathering. So we have rain coming in. We have the lower temperatures in the winters and also higher temperatures in the summer seasons. So this cycle goes on and on. So this particular temperatures, including other natural entities like air, we can say, water. So these all are the carriers where it is creating the weathering action on the rocks. So the next is related to the properties like porosity and void ratio, right? So there are multiple properties where the rock is getting changed in the due course of time due to the weathering action. So now I will say that sandstone and granite, limestone. So which kind of rock related to which type of capacity? So the limestone, generally it will be a soft mineral. Sandstone is better than that, and rock is more better than that. So the type of mineral that is helping to form this kind of materials is a very important aspect for the formation of the material, and thereby as the type and mineral changes, the strength aspect, the durability aspect of the rock changes as the mineral changes. Here, soft minerals are easily broken apart and crushed, whereas harder minerals is quite difficult. That is what I am highlighting, that limestone, calcite, fine. So sandstone, and again granite rock, marble rock. So every material has its own compression strength, has its own hardness. So there are multiple parameters where we can assess the type of the rock in terms of physical and chemical means, so that it can be used for various applications. So the next is the arrangement of mineral grains and size of a rock control the entire weathering process. So in our future classes we will also be learning that there are fine grain mass, coarse grain mass. So during the formation, when the grains are suppressed with lot of pressure and heat, like in lava formation, we have seen that granites are formed. Whereas in the sedimentary action, okay, so we can see that there is some soft mineral that has been produced. So this entire process is purely dependent on the arrangement of mineral grains and the size of rock. So example, some of the rocks susceptible to weathering that are limestone and marble. So we have heard a term called leaching. So when water is coming in contact with water, we can see some acid pH level water is going to be leached into the ground. So next is the another example would be for a dense or a hard rock or a harder mineral is granite, which is formed with the help of silicates, iron oxide, etc. So it disintegrates and alter mineral and rocks near or at earth surface. So the each process has its own distinct effect on rocks and minerals. So during at the conclusion, that I can say that the weathering of rocks recedes the UCS value. What is this UCS? Unconfined compression strength value. So as the type of rock, if it is a soft material, the UCS value is obviously low, and the bearing capacity of the material will obviously be less than the required limit. And as it is vice versa to the harder material, example granite. So now coming to the point, what is weathering of rocks? The deteriorating effect due to weather, climate, atmosphere agencies on rocks may be described as weathering of rocks. Very, very important. The deteriorating effect due to weather, climate, and atmospheric agencies. What are these atmospheric agencies? Rainfall, low temperatures during winter, high temperatures during summer. Like it's like a freezing and thawing effect on the rock material, where continuously this cycle is going on. Because of this cycle, the wear and tear of the material is taking place due to this atmospheric agencies, that is by nature, and thereby the weathering of rocks takes place. So the different kinds of rocks which are formed under different conditions undergo disintegration and decay when exposed to Earth's surface. So two important classifications that exist, that are physical weathering and chemical weathering. So what is physical weathering? Physical weathering is like mechanically the breakdown of the material takes place with time. Soils through direct contact with atmospheric conditions such as wind, heat, water, ice, and pressure. Frost action, ice wedging, temperature changes, thermal expansion and contraction. So salt weathering, crystallization of salts in cracks causes expansion. Wetting and drying of the material. Organisms, roots, action of plants or burrowing animals, etc. So we will see in detail about the physical weathering now. So the thermal stresses, as we have discussed in the previous slide, that there are some atmospheric agencies. So one of those is thermal stresses. Weathering, that can occur in a desert climate that is hot during the day and cold during the night. So the heating and cooling processes that happen every day put stress onto the rock on the outer layer, and it starts peeling out. Causes started peeling off of the inner thin sheet, and thereby it breaks with time. The other effect is basically the frost action. So during rainy season, all the cracks are filled with water, and this particular water, when the temperatures are going down, and it becomes in ice, and when the water is converted into the ice, the volume of that particular source of water is going to increase, and then the cracks of the rocks is still increases, and thereby this failure of rocks may happen. So frost action is one of the root cause for the split of rock and also the failure in the rocks. Next is vegetative action. We have already seen in the introductory slide that plants, animals which are burrowed inside the rocks, or sometimes this birds or some kind of elements may be passed, like the seeds that are inside the rock material where there is a scope of growing as a tree. So as the time passes, so with the increase in the life of the tree, the expansion of the rock takes place, and thereby it started splitting. So the plants and animal roots force the way into cracks, animal uncover the rock and it's to the elements. So temperature action. Temperature changes, again it is more or the less which we have discussed in the first part, thermal stresses. So temperature changes altering hot and cold temperatures weaken the rock, and it expands and contracts. So physical weathering. So whenever there is some rocks that are present near to the shore, so whenever the water is coming onto the shore and going back, and also whenever there is some large winds that are traveling, due to this the aberration, the why, because this wind also carries some stone particles. So this the which induces the wearing and tearing of the top layers of the material, and by time it starts reducing its volume due to the aberration effect. So aberration pieces of rocks collide with each other due to transportation of wind, ice, water, and gravity. Now, next moving to the other part, which is the chemical weathering. Chemical processes altering the nature of earth material, solution by acids, hydration and oxidation, salt weathering, wetting and drying, organisms, root action of plants, and burrowing animals. So, if we see in detail about the chemical weathering involves the direct effect of atmospheric chemical or biologically produced chemicals in breakdown of rocks, soils, and minerals. When water comes in contact with granite, feldspar crystals inside the granite react chemically, forming clay minerals. So the clay weakens the rock and making it more likely to break. Example of this type of weathering is rust formation, which occurs when oxygen reacts with iron Fe to form iron oxide rust. So in the subsequent slides, we can see how that Fe or iron is involved in the process of weathering and in the formation of rust, etc. Rust changes the color of the rocks, plus iron oxide in much more fragile than iron, so the weather region becomes more easily to break. So this is an example where we can see this part which is in the rust over part, where the it gives an evidence that the presence of Fe is available at this particular location. Next comes is carbonation. It occurs when the combination of carbon dioxide in the air to form carbonic acid, and carbonic acid easily dissolves the rock like limestone and marble. So that is what like when we are talking about the leaching effect. So when the when the water which is combined with the CO2 in the air to form carbonic acid. So carbonic acid easily dissolves rock like limestone and marble, etc. So we have seen some part of introduction of the weathering action of rocks. So how to recognize that? Weathered rocks usually develop deep brown, red, yellow color on the surface. Weathered minerals exhibit change in color intensity and strength. So they lose their natural original shine and fresh appearance. So they become less transparent and tend to become opaque, etc. So these are the various examples of engineering properties with time and weathering. So we can see that the dolerite of grade 1, 4, 5 and grandolite of 1, 2, 3, 4, 5. So it has various engineering values which is given which is after the sorry which is after David George Price 2009. So here the density of the dolerite third phase is third class is 27.64, whereas the density of high grade is around 28.4. So we can see that unconfined compression strength values, the unconfined compression strength values are higher and higher as the grade is increasing to the basic grade to the upper grades. We can see here. So we can also see that the UCS values of the minerals are coming down, so which denotes that from a harder material to it is converting into the lighter material with time. And also the unconfined compression strength test results are also seen here, and also the seismic velocity values, etc., and also the shear wave velocities, and also skimmed hammer values, etc., and rock mass friction and rock mass cohesion, etc. So we are going to see about the example for variance in engineering properties with weathering. So these are the minerals which are halite, calcite, olivine, Ca palyglois, pyroxene, amphibole, sodium palyglois, biotite, orthoclase, muscovite, clays, quartz, gibbsite, etc. And the slowest weathering material is hematite, etc. So this image shows the mineralogical properties of various minerals, which is quartz material here, and also the quartz of different shape here. We can see it is biodine. Again here it is quartz. Here it is quartz. So this might be quartz based on the mineralogical calculation. So here we can see the deterioration of rock is taking place with time. So the rock properties are drastically changing. That is what it is telling, that with the time passes, the mineral properties loses, and thereby the rocks become soft, and thereby the engineering properties of the rock may get loosed. Next, another example is like felt clay. Again, here it is quartz, and here it is iron, etc. And again, it is quartz type sample. So mostly quartz is the mostly the silicates SiO2. The next is the variation in point of load carrying capacity with weathering. So we can see Phyllite, Meyerlite, Landsberg. So we can see the values of unconfined compression strength. We can see it is in MPa where it is near about 44, which is 4.4 etc. at 4 by 5. And again here we can see that in the earlier slide we have seen that there are cases like 2, 3, 3, 4 and 4 etc. So the importance of weathering with reference to dam, reservoirs and tunnel. Weathering is a process that plays a major role in engineering mechanics, kinematics, dynamics, fluid mechanics and mechanics of material to predict the mechanical behavior of erosion. So on weathering, bedrocks downside to smaller and movable pieces which transport through water flow. So through erosion and the surface of the earth is constantly being sculptured into the two new forms. So the shape of continents are continuously charging as waves and tides cut into the old land while the silt from the rocks builds up new land. So this is the most interesting image we can see here. Pangania, Gondwaland, Laurasia and Tethys. Okay, so 225 million years ago, 200 million years ago, 150 and 65 million years ago, we can see that there is a place called Pangaea which is together. So after 25 millions, less of 200 before 200 million years, so there is some weathering process that has taken. It might be of any case. We can't say that it is due to the physical weathering or chemical weathering etc. So here the distance has been still increased, and here also. So just before 65 million years, so there is a huge space where a human being can easily enter. The next is again you can see here it is following the same. So now it is India, Asia, Africa, South America, North America, Antarctica, Australia. Can we see the difference and with the earlier existence and the current existence? Yeah. So the importance, next slide. So this is the bedding plane which it is around, arranged in various folds and faults region which can be seen here. So again there are some different faults that are available. So reservoir majorly affects due to weathering. It possesses huge catchment area which is in contact with soil and rock. So weathering results in decrease of reservoir capacity etc. So this is again the application of some rock where the rock is cut for further use for the preparation of tunnel etc. So again here we can understand the importance of geology. So the soft rock may be available at this particular place. So sedimentary rock at the tunnel site etc. So metamorphic rock at this tunnel site. So there is a process called gunneting or concreting which is happening here. So just after the cutting of that particular place, so the complete tunnel is being concreted, or it is like gunneted for not to create any havoc due to the external forces. So the next is fold set tunnel, which is one of the problem. And weathering of common rocks, granite is the most common and widely occurring type of intrusive felsive igneous rock. Granite usually have the medium to coarse grain. So weathering process affecting granite, so chemical weathering, hydrolysis, oxygen and hydration. So physical weathering, freeze thaw, weathering isolation, sudden postration due to exposure to sun of excessive heat. Weathering, salt crystal and pressure releases. So deep weathering causes up to 30 to 60 meter. So what are the factors? And these are the some additional factors where deep weathering is caused in zone 1, 2, 3 and 4 etc. And various zone has its own importance. So that is what I would recommend you people to look into the current video along with the presentation that is being presented here, so that you will have some additional information known to you to understand the weathering of rocks, etc. Thank you. We will meet in the next class.
Like, share and subscribe. Hit the bell icon for more updates.